This video shows you in part how rocks are prepared for view under a microscope. We'll start with the oil saw. This is our technician Bill. He's clamping in the rock in preparation for cutting it with that circular saw blade. It's important that he clamps it in so the rock remains steady as it's being cut. The oil saw is generally used to cut flat slabs from bigger rocks that are too big to be cut on other saws. He has to close the lid to keep the oil contained. Now he's turned on the saw blade and he loosened the knob that will allow that weight to pull the rock toward the blade in order to cut it. You may notice the oil everywhere. The oil saw is called an oil saw because it uses oil as a lubricant. This stops heat caused by friction from shattering the blade or otherwise damaging it. This saw blade does not have teeth like a blade that would be used to cut wood, but instead uses commercial-grade diamonds to grind down the rock. So he's made one cut, but he still needs a flat slab, so he'll make another cut. Here's the finished slab. This part will be cut down further. The other parts of the rock will be saved for different analyses. For now, he's going to wash the rocks just to minimize mess in the lab. We don't want oil all over the other equipment or on the tables, so we even put them in the dishwasher to get them really clean. Now Bill is looking for features in the rock he would like to see up close. These could be mineral alignments or other clues that can help us figure out the geologic history of this rock. The rectangle he's tracing around is what he will cut out on the water saw. This is the water saw. It uses water to cool down the blade and to prevent dust from becoming airborne. This saw blade is another diamond blade and does not have teeth. Nonetheless, Bill is always careful to keep his fingers out of its path. Here's the finished product. We call this a billet. It will be shipped off to a lab and mounted on a glass slide to create a thin section like the one seen here. Geologists can look through a petrographic microscope to see the minerals that make up the rock. The rock's composition and its orientation may provide clues about its formation and history. Here's what a thin section looks like under a microscope. Here's what it looks like under cross-polarized light. Thank you for watching.